Welcome to qnawire.
So, because there is no external torque applied to the wheel clay system, the angular momentum will be conserved. So, L1, which stands for the angular momentum, the total angular momentum before the clay is thrown, is equal to L2, which is the total angular momentum after the clay is thrown. Now, we assume that the clay is thrown with an angular momentum so that we assume that the clay is thrown with no angular momentum so that its initial angular velocity is zero, and therefore the initial angular momentum for the clay is zero. This problem is similar to problem 10. So the situation is a totally inelastic collision in which the final angular velocity omega f is same for both the clay and the wheel, and let's call it omega f. Now L1 and L2 stands for the total angular momentum. So L1 is initial angular momentum for the clay plus initial angular momentum of the wheel, and we write the same for the final angular momentum. And since initial angular momentum for the clay is zero, we finally arrive at this expression. Now, angular momentum is given by I times omega. So we have I1 omega 1 for L1 omega to be equal to I2C omega f plus I2W omega f. And this is because they have the same final angular velocity. So from here we can write the expression for the final angular velocity. So this will be equal to I1 times omega 1 over I2C plus I2W. And as you can see, I1 is equal to I2W, which stands for the wheel. And this is equal to half mass of the wheel times square of radius of the wheel. And similarly for the clay, this is equal to half of mass of the clay times square of radius of the clay. So we write that expressions over here. So we get omega 1 times half of mass of the wheel times radius of the wheel square, half of mass of clay times square of radius of clay plus half of mw times mw times rw square. Now we are given the radius of the wheel to be 0.2 meter. Mass of the wheel is given to be 5 kgs. Radius of the clay is equal to 8 times 10 to the power minus 2 meter, and mass of the clay, let me write it here. So mass of the clay is equal to 2.6 kg. Now we use these values in this equation provided our omega 1 to be 1.5 revolutions per second. And we solve this equation and we get the final angular velocity for the wheel clay system to be 1.385 revolutions per second.